not a good Monday morning, guys. It's just flashing it. Maybe. All right. If I said x plus 4 over x squared plus x minus 1, can you divide that so it's just x to a power? No. We could only simplify it if it were a single term on the denominator. If I said something like e to the x times x squared plus 4, can I write that so I no longer have things being multiplied together? Even if you distribute, you have e to the x times x squared. It's impossible to totally get rid of that product. So we have to have these other options. So for our product rule, when you have things being multiplied together, I can give you a big long explanation, or we can just talk about the rule. If you have the derivative of two functions being multiplied, it's the first times the derivative of the second plus the second times the derivative of the first. Essentially, you take one derivative at a time. Okay, it doesn't really matter, we're adding, so does it matter which one you do the derivative of first? No. Another way to write this, just think like f times g prime plus f prime times g. So one derivative at a time. Adding so terms can be interchanged. So let's actually try that with one. If I gave you this one, last week if I'd given you this problem, you would have multiplied everything out. If I tell you to do this derivative without multiplying it out, that is our product rule. So we have to first make sure we can find the two things being multiplied. So in this case, it's pretty easy, the two parentheses. So our derivative. We do one at a time. Does it matter which one I do the derivative of first? Not at all. So if you wanted, what's the derivative of the first parenthesis?
Oh, wait, we can do the simple.
Yeah.
Just make it 12x to the second.
So if I were just doing that derivative of 1 is 0, 3 comes down, so negative 4 times 3 is negative 12, x, you subtract 1 from the power. Second one stays the same. Plus, now the first one stays the same, times the derivative of the second one. What is the derivative of the second parenthesis?
6x minus 5.
So we did one derivative at a time. Could we simplify from here? Yeah, at this point you could now multiply things out. So that would be negative 36x to the 4 plus 60x cubed minus 24x squared. How would I simplify the second one? What would I have to do? FOIL that. So we get 6x minus 5 minus 24x to the 4 plus 20x cubed. Adding like terms. So I get negative 60x to the 4th plus 80x cubed minus 24x squared plus 6x minus 1. All right, was that faster? I don't know, multiplying out the first one probably wouldn't have been all that terrible. So did it save us a lot of time? Maybe, maybe not. But it is another option. In some situations, we would not have been able to multiply out the original. So it is important. Sometimes it's faster to multiply first, sometimes it's faster to do the product rule first. It just all depends on the problem. But you should get the same answer either way. So let's try one where we have to do the product rule. So x times e to the x. I can't simplify those and make one of the x's disappear. It's a product rule because I have two expressions that both have an x in them. I have a plain x and I have an e to the x. So if I want my derivative, we do one at a time. So the derivative of x is what's the derivative of x?
Just
1 times e to the x plus the first one was x times what's the derivative of e to the x?
That's just easy.
It's still e to the x. So I just get e to the x plus x e to the x. B. I want the nth derivative. I'm asking you to find a formula for getting these derivatives. So we're probably going to have to do more than one before we can find this pattern. So if I did my second derivative, that's the derivative of the answer we just got. Now it has more than one term, so we have to do the derivative of each term. So the derivative of the first term is still e to the x. Plus, to do the derivative of this term, we have to do product rule. Derivative of the first, so derivative of x is 1 times the second, plus the first times derivative of e to the x is e to the x. So then e to the x plus e to the x would be 2e to the x plus x e to the x. Do you see the pattern? What do you think the third derivative would be?
3 plus x e.
We wanted to check it. Derivative of 2e to the x is 2 times the derivative of e to the x is still e to the x. Derivative of x e to the x, product rule. Derivative of the first times the second plus the first derivative of the second. We get 3 e to the x plus x e to the x. So my nth derivative would be what?
In e to the x plus x e to the x.
Perfect. Because the first derivative had 1 e to the x, and we still had the x e to the x. Second derivative was 2 e to the x plus x e to the x. Third derivative, 3 e to the x plus x e to the x. So we can see all that's happening every time is we add another e to the x. All right. Questions on? Let's practice some more. Right. Could I multiply this one out if I wanted? Sure. I'm going to do the product rule to practice it, but just know, like, on a test or a quiz, if I just say find the derivative, you can do it any way that works for you. It would, no matter what, probably be helpful if instead of writing a square root of x, that would be x to what power? 1/2. So if I'm doing the derivative, what's the derivative of this first parenthesis?
3.
And the second one stays the same. Plus, first parenthesis stays the same, times derivative of the second parenthesis. What's the derivative of x? Plus x to the 1/2, so the exponent will come down, x subtract 1 from the power. All right, if I asked you to go ahead and multiply this out to simplify, could we? Just distribute, we get 3x, 3x to the 1/2. Over here we FOIL, so plus 3x. Plus 3/2, you add powers, 1 plus any 1/2 is positive 1/2. So like terms, 3x plus 3x would be 6x. 3x to the 1/2 and 3/2 x to the 1/2. So 3, that's like 6 over 2 plus 3 over 2. So 9 over 2. Are there questions on this product rule right now? I'm going to skip a little bit. I want to go down and talk about the quotient rule next. So quotient means division. If things are divided, the expression gets a little bit more complicated. It's the denominator times the derivative of the numerator minus the top times the derivative of the bottom over the bottom squared. So that's a little bit nastier. To try to remember it, I always say low d high minus high d low over low squared. So this time, unlike with the product rule, it really didn't matter which one you did the derivative of first because we were adding. When you're subtracting, order matters. So we do have to be careful on that. So let's walk through one and I'll kind of explain as we go. I'm going to start with a fairly easy one. Now this one, would it be easier to probably simplify it first? Absolutely. But since I'm teaching you the product or the quotient rule, I'm going to use the quotient rule to get it. So the derivative is low, so that's the bottom. D high means derivative of the top. So what's the derivative of the top?
20x to the 3 minus 6.
So low d high minus high, so the top. D low, derivative of the bottom.
4.
Over low, so the entire denominator squared. low, d high, minus high, d low, over low squared. Then we could multiply things out to simplify it. So then you get 40x to the fifth minus 12x squared. In this one, I'm going to distribute my negative and my 4x at the same time. So it'll be minus 20x to the fifth, 24x squared, minus 28x. On the bottom, if we square that, we get 4x to the fourth. Combining like terms, so 20x to the fifth, that's 12x squared minus 28x. What can I divide everything by? A 4 and an x, so if I take a 4x out of everything, I get 5x to the fourth plus 3x minus 7 over x cubed. I just want to show you that this is in fact the same as the answer we would have gotten Friday, so you don't have to write this out. But if I put this on your quiz Friday, the first thing you would have done is reduce this. So you'd have 5 over 2. When you're dividing, you subtract your exponents. Minus 3x, 1 minus 2 would be negative 1. Plus 7 over 2, x to the negative 2. And so then when you did that derivative, exponent comes down. So you would get 5x plus 3x to the negative 2 minus 7x to the negative 3. Are these equivalent? If I take 5x to the fourth divided by x cubed, I get 5x. 3x over x cubed is 3x to the negative 2. Minus 7 over x to the third would be minus 7x to the negative 3. So equivalent answers. The other method, definitely way faster. But you can't always use it, so that's why we have to have our quotient rule. So let's look at one where we could not use this shortcut. So if I gave you a problem like this, because I have 2 terms on the denominator, I could not do this without quotient rule. So quotient rule says low, that's your denominator, so x cubed plus 6. D high, what's the derivative of the top? 2x minus high, so just the top of the fraction. D low, derivative of the bottom?
3x squared.
Over low, so the entire denominator, squared. Going ahead and multiplying it out to clean it up a little bit, so we'd have to FOIL here. We get 2x to the fourth, plus x to the third, 12x plus 6. I'm going to distribute my negative and my 3x squared, so minus 3x to the fourth, minus 3x cubed, plus 6x squared. The bottom, I'm not going to square that. You certainly could, but it's not really going to help me in any way. I don't have any like terms to combine, so I'm just going to leave it as x plus 6 squared. So all together, we get negative x to the fourth minus 2x cubed plus 6x squared plus 12x plus 6 over the denominator. questions on that one? The last problem for today, I would like for you guys to try this one on your own. O is the actual denominator. D high, derivative of the top of this fraction. So we just have a 1 on top, 1 is a constant, derivative of any constant is 0. Minus high, so the actual top of our fraction. D low, derivative of the bottom, so the derivative of x squared, the 2 comes down, keep the x, subtract 1 from the power, plus derivative of 1 is 0. Over low squared. So you should get negative 2x over x squared plus 1 squared. Or, I did see a couple people that did multiply out the bottom. If you do that, it would be x to the 4th plus 2x squared plus 1. So either of those answers are okay. So what I want to do now, we have quite a bit of time left. I want to stop and let you guys practice these rules individually. So I have a handout. The front, there are some problems that you might be able to multiply out rather than doing the product rule, but for today only, let's do the product rule just to practice that. So front is all product rule, the back is quotient rule. 10 questions.